So today we are going to start our maths second. Uh, it is algebraic expression 11th exercise. From here, math second is starting. Okay. So for math second for algebraic expressions, first we have to know few basic things uh, like constants and variables. What are the constants and what are the variables? First, let's focus on constants. Constants are those uh, terms uh, which has fixed values, like if you see 3048 minus 4 by 9 13 by 10 20, so these are fixed values. Okay, so these are constants. But variables means where values are not fixed. Okay, like any algebraic any term like x y z, so we don't know the values of these terms, so these are variables. The values of these term could be any number. And what is algebraic expression? So in algebraic expressions there are constants and variables with the various signs like positive, negative, division and multiplication, like 5xy. Here in this term 7x square minus 4y. So 7 is constant, x is variable, and minus sign 4y. And here 6x minus 5y plus 2z. So constant and variables with the various signs. um, and what are the like terms and what are the unlike terms? In like terms, variables have similar powers, like here 4t, here power of t is 1, and here 3t power of t is 1, and here 7x square y 5x square, x square y and yx square. So these are similar terms because the degree of these variables and these variables are same. So these are like terms. But in unlike terms, degrees of variables will be different. Like here 3x and here 4xy. So here variables are xy and here is variable is only x. So these are unlike terms. And here 3x square y. So degree of this term here, degree of x is 2 and y is 1. Here x, degree of x is 1 and y is 2. So degrees are different. So these are unlike terms. And how to find out the coefficients? So finding out the coefficients, just look at here 24xy. So here in this term 24 is the uh, constant. Okay, numerical coefficient. 24 is numerical coefficient and xy is literal coefficient. Types of algebraic expressions. So expressions having a single term with whole number exponents are called monomials. Mono means one. So monomial where the only one term is available. Like here 7 is monomial, x is only one term, minus n xy is only one term, 0.8 x to the power 4 it is one it is 0, one term 8, one term x to 8x to the power 4 is one term. So these are monomials. But here if you see uh, here in this term minus 7x to the power minus 1, so power is x is negative. So first of all, this is not a polynomial. Polynomials always having positive integral powers. Okay, so this is not a polynomial. And here it is and here in this term power of x is negative, so it is also not a polynomial. What are the binomial? Bi means two. So where the two terms are available, those are known as binomials. Like here, x is one term and another term is 2y. Okay, and here 3x square and another term is 7y square. Here 2x square, one term, and minus 5y square is another term. So these are binomials. Tri means where the three terms are available. Here x minus 2y and 3z, three terms. So it is a trinomials. Where more than three terms are available, those are known as a polynomials. Poly means many. Okay, like in here, these are polynomials. Polynomials is a monomial or a sum or difference of monomials. Like here 5 is monomial and 6x is monomial. So when we add, so we'll get polynomial. Okay, poly means many terms. Okay, so it is a these are polynomials. Here polynomial in two or more variables, where like in the first example 3x plus 3y square plus 3xy. So here uh, two variables are available, xy. So two variables are here, and the degree of a polynomial is the sum of the exponent of two variables. Here x and y, just add the powers of these variables. Power of x is 1, power of y is 1. So 1 plus 1, 2. Here power of x is 2, y is 2. So add 2 plus 2, 4. So degree of this polynomial is 4. Which of the following algebraic expressions are polynomials? Polynomials. Okay. So our first question is 5 minus 7x. 5 minus 7x. So this is a polynomial. Why this is a polynomial? Because the power of this term is positive. Okay, power of x is 1 here. Here power is 1. So positive integral power. So it is a polynomial. And second is y cube plus 4y9 y to the power 4 minus 11. Here the powers of variables is a positive integral, so it is also a polynomial. uh, Third, y square minus 2y minus 7.8 upon 3 y to the power 4 plus 2.5. Okay, this is not a polynomial. Why? Because this term is in the because variable is in denominator. So if we solve this term, the power will become negative. So it is not a polynomial. Okay, and the fourth is 2 minus 9 by x. This is also not a polynomial. If I solve this equation, 2 minus 9, x will become like this, power minus 1. So if power is minus 1, then this will not be a polynomial. Not a polynomial. Okay, and the fifth question is 0.8 minus 1.5x plus 4x square minus 6x cube plus 7x to the power 4 minus 2x to the power 5. So here the these powers are positive integral. Okay, so this is also a polynomial. And the sixth question is 7.3. It is also a polynomial. Why? If I can write this in this way also. Okay, So 0 is also a whole number. So this is also a polynomial. And seventh is 3.4 z. So power of z is 1. So it is also a polynomial. And eighth part is x plus 1 upon 3x minus 2. Okay, here. So here again, this is a polynomial because x is in denominator. Okay, so in this way we have to find out which terms are polynomial and which are not. State the numerical coefficient and degree of each expression. So first, it is a if it is a monomial. So 45, it is a monomial. Okay, and how to find the degree of this term? We can write this term in this way: x to the power 0, because this is the value of this term is 1, so degree will be 0. Degree is 0, 4 a square upon b. So this is not a monomial. Why? Not a monomial. Why? Because this is in denominator. Okay, and third is and question number third is 42 x to the power 1 by 4. So this is also not a not a monomial. Why this is not a monomial? Because the power is not a whole number, it is in fraction. Fourth, 9b. Okay, so it is a monomial and degree is 1. Degree is 1 because the degree of b is 1. And fifth, 1 by 8 p q. Okay, this is a monomial. Okay, and what is the degree? Degree of this term will be add the degrees of p and q. So degree is 2, and degree is minus 12 m square n. So it is a monomial and degree 2 plus 1 3, degree is 3, and the numerical coefficient is minus 12 is numerical coefficient. Okay, and in seventh, uh, 5 upon t square. So this is not a polynomial, not a monomial. Why? Because it is in denominator. And question number 8, c square plus 13. So this is not a monomial, this is a binomial. Okay, this is binomial, not a monomial. Why? Because here are two terms, c and 13. And question number Question number 9. Root uh, root 7 d cube. So this is a monomial, and degree is 3. Okay, and the last one is question number 10th. Minus 2 by 3 x square y to the power 5. Okay, so this is a monomial, and degree is 2 plus 7. Degree is 7. 2 plus 5 is 7. So in this way we have to find out the degrees of monomials, and the coefficient is numerical coefficient is minus 2 by 3, and here numerical coefficient is root 7. Okay, so in this way we will find question number 3. Select like monomials. Select like monomials. So first term is 7 minus 3x plus 8. 7 minus 3x plus 8. So like terms where the variables having similar power. So here 7 and 8 are the like terms, because here degree of these terms is in both 0. So so like terms are 7 and 8. Okay, and question number 2, a plus b plus 2a minus c. So here like terms are a and a, because degree of a is 1 in both. So like terms are a and a plus 3b minus c plus 5d 5 5b, sorry. So here uh, 3b and 5b, degrees of both is 1. So like terms of 3b and 5b. Question number 4th. 2xy minus 5xz plus 4yz minus yz. Okay, so here uh, just see the variables here, xy and here xz. So both are different, but here yz and here yz, and degrees are also here degree of y is 1, here y is 1, degree of z is 1, degree of z is 1. So like terms are 4yz and minus yz. Okay, we'll higher plus m square n square minus 2 m square n plus 6 m square n square. Okay, so here just find the similar like terms, either here m square mn square, and here no other mn square. So and here m square n square, this term, and m square n square, this term. These are like terms. So m square n square and 6 m square and n square, these are like terms, because degrees are here 4, 2 plus 2 4, 2 plus 2 4, and 6 2a b square c square minus 7 a square bc plus 9 a square b square c square plus 8 a square b c square. Okay, so here a b square c square, and no other terms are available, a square bc, and this is also not similar terms with this, and here a square b square c square, and so Here, no like terms. These are unlike terms, so no like terms. 8 r plus s minus 3 r plus s plus 5 r minus s. Okay, so just open these brackets. 8r plus 8s minus 3r minus plus minus 3s plus 5r minus 5s. Okay, so in this equation we have to find like terms in which, okay, so like r r uh, and these are like terms, means 8r minus 3r and 5r, these are like terms, and 8s minus 3s and minus 5s, these are like terms. Okay, in this way we have to solve this question. In this question, state the degree of each polynomial. Okay, and we know what are the degrees. Okay, so first question is minus 19 upon 15. So here in this term, there is no variable. Okay, we can write this term like this: 19 upon 15 into x to the power 0, because value of this term is 1 and the degree of degree is 0. So degree is 0. Second question, 16 upon 31 y to the power 100. So here degree is 100. Okay, and third is easy. Fourth in question fourth, 3 q to the power 4 plus 5 q to the power 8. So here in this term, there are because we always see the highest power. Okay, so degree is 8. And question number 5, 8 aq b to the power 5 plus a square b square. Here in this term, we have to add these exponents. 3 plus 5 8 and 2 plus 2 4. So degree is this 5 plus 3 8, because it is maximum. So degree in this case will be 8. And question number 6, 3x to the power 7 plus 15 plus x minus 2x to the power 10. So here the highest power is 10. So the degree is 10. And question number 7, 0.5 x cube y plus 0.25 x y square plus 6x to the power 5 plus 0.75. Just see carefully in this term. Here 3 plus 1 4, here 2 plus 1 3, but here is the maximum 5, so degree is 5. Okay, so in this way we have to find the degrees. Tell whether the given polynomial is a monomial, binomial, trinomial, or none of these, then state the degree and the coefficient of the polynomial. So first we have to check which is a monomial, binomial, trinomial, and also find their coefficient, degree and coefficient. So first is 5c square d. So here here is only one term. This is one term, so it is a monomial first of all. Okay, and coefficient, numerical coefficient. First find out the degree. 2 plus 1. So degree is 3. Degree is 3. Okay, and and coefficients. Numerical coefficient is numerical coefficient is 5. Okay, and literal coefficient is c square d. Okay, so in this way we have to find the term, degree and their coefficients. 12 b c minus 8 square b square c square. Okay, so first is this is a binomial because this is one term and this is second term, so it is a binomial. Okay, and degree here add these coefficients. 1 1 1 degree is 3. Here 2 plus 2 plus 2 degree is 8, sorry 6. So degree of this term is 6. Okay, and now the coefficient. Here the numerical coefficient is 12, and here numerical coefficient is minus 8, and here literal coefficient is ABC, and here literal coefficient. Arrange the given polynomials in order of decreasing degree in x. Okay, so first question, 4x plus x square and minus 8. So we have to arrange this polynomial in the decreasing degree of x. So highest degree is x, so it will come first. Here degree is 1, 4x, and here degree is 0, so minus 8. Okay, in this way we have to arrange these terms. Now the second question, 8x square minus 3x to the power 4 minus 12 plus 6x cube. Okay, so the highest power is this, so this term will come first. Minus 3x to the power 4. Then this will come plus 6x cube, then plus 8x square, then minus 12. Okay. Question number third. Question number third. X square y minus 3y cube plus 4x cube minus 2xy square. So here are two variables x and y, but question is saying that arrange in the decreasing degree of x. Okay, so we'll see only x. So the highest power x is this. So 4x cube, then x square plus x square y, then x minus 2xy square. Here x is 0, power of x is 0 here, so minus 3y cube. In this way we have to arrange this equation, this polynomial. In the same way we will do question number 4. So try the question number 4. Okay, just do this question by yourself. The question is saying write each polynomial in standard form. polynomial in standard form. So what is the standard form? Just take the first question. I'll tell you what is the standard form. 17 minus 3x square plus x to the power 5 plus 8x cube. So the standard form is to arrange in their from highest to lowest power. The highest power is here. So x to the power 5 plus 8x cube minus 3x square plus 17. So this is the standard form because the power of x is decreasing 5, 3, 2 and here is 0. So in this way the second question will also be done. Try it. I am going to the question number 8. Question number 8. In this question we have to evaluate if values of variables are given. Value of A is 2, value of B is 1 and value of C is equal to 10. Okay, so these three values are given. So take the first question. It is very simple. Evaluate C cube. C cube. What would be the value of this term? So we know the C is 10. So here just put the value of C is 10 and cube means 3 times multiply. Okay, this is, so the value of this is 1000. Okay, and this way we have to evaluate these terms. And question number second, bracket 2b square. So first put the value of b 2, value of b is 1. So just write it 1 over here. So value of b is 1. Okay, 1 here. And just put this bracket also, this bracket and a square. Okay, 2 1 are 2. So here 2 1 are 2, 2 is square. The square means 2 into 2. So value is 4. Question number third. C plus B whole square. Okay. C plus B, so just put the values of C and B. Value of C is 10 and B is 1. So 10 plus 1 whole square. Just add these two numbers, 11 whole square. So 11 whole square means 11 into 11. And just multiply this, you will get 121. A minus 3 whole square. Okay, I am writing the values of here. A is 2, B is 1 and C is 10. Okay, so A minus 3 whole square. So it is all simple, just try this question. We will do the question number 5 sorry. 1 by 2 C whole cube. Okay, first put the value of C. C is 10 here. So 1 by 2 C is 10. So this here is sign of multiplication. So 10 cube. So just solve this, 2 5s are 10. Okay. So just cut it. 2 5s are okay. So here 5 1s are 5. 5 cube. 5 cube means 5 into 5 into 5. 5 5s are 25. 25 5s are 75. Sorry, 125. 5 5s are 25. 25 5s are 125. Okay. So this will be the value of this term. Then question number 6. Question number 6 is 3a cube upon b. So first put the values 3. Value of a is 2 cube, and value of b is 1. Okay. Just solve this. 2 cube means 8. Value of 8, 8 is a 24. Okay. Question number 6 has done. Now question number 7, 8, 9 and 10. Question number 7. So question number 7 is saying 9 bracket a square minus b square. So 9, we know the value of a is 2, 2 square, or value of b is 1, 1 square. So first solve this bracket. 2 to the 4 minus 1, 9, 4 minus 3, 4 minus 1, 3. So bracket 3, 9 3 is 27. Okay. Question number 8. 3b a cube minus c. So value of b is 1. So just put the value of b is 1. This is b. Okay. And a value of a is 2. 2 cube minus c, 10. Value of c is 10. So 3 1 are 3. 2 cube means 8 minus 10. Okay. Just here 2 cube. 2 cube means 2 into 2 into 2. 2 to the 4, 4 to the 8. 3, 10 minus 8 minus 2. 3 to the 6 minus 6. Okay. And the question number 9th and 10th. Okay, you will do the question number 9. You just do this question. Solving question number 10th. Minus a minus b plus c whole square. Just put these values. Value of a is 2, value of b is 1, value of c is 10 square. Minus 2 minus 1 minus 3. Okay. Minus 2 minus 1 is minus 3 plus 10 square. Minus 3 plus 10. So it will become 7 square. Okay. And 7 into 7, 49. So value of this is 49. So in this way we have to evaluate these terms expression for the following situation. Okay, so first situation is Rita's age is 4 less than 4 times her daughter's age. Rita's age is 4 less than 4 times her daughter's age. X. So her daughter's age is X. So Rita's age is 4 less than 4 times her daughter's age X. So 4 times of the daughter's age is X, 4x. Okay, and Rita's age is 4 less means minus 4. So this will be the equation. Question number 2. Just read this question in your book. The expressions for 3-digit number when the hundreds digits is A, tens digit is B, and the units digit is C. So hundreds digit is A, tens digit is B, and units digit is C. Okay, so this is a three digit number. So how to write a three digit number? Suppose if I take any number, this is for the sake of understanding. Okay, so 125. This is unit place, this is tens place, and this is hundreds place. So how this number is formed? So 100 into 1, this is okay, plus 10 into 2, this tens place, plus 1 means unit place is 5. Okay, just solve this. 100 plus 20 plus 5, so this will become 125. In this way we have to write the number. So here we have 100 is A, tens is B, and unit is C. So just here 100 into A plus 10 into B plus 1 into C. So this is 100A plus 10B plus C. So in this way we have to write a three digit number. Number third is saying the perimeter of an isosceles triangle. Isosceles triangle. Isosceles means where two sides are equal. Means suppose this is a triangle where these two sides are equal. So this is a isosceles triangle, and it is given that the equal length are P and the unequal length is Q. So the perimeter we know is the sum of these sides. So add these sides plus P plus Q. This is 2P plus Q. So this will be the perimeter. And the question number 4. The speed of a bus is z meter per second. Speed of a bus is z meter per second. Okay, and we have to convert this into kilometer per hour. So there is one thing I want you to remember. Whenever we have to convert meter per second into kilometer per hour, simply multiply by 18 by 5. Okay, then it will become kilometer per hour. And we have when we have to convert from kilometer hour to meter per second, then multiply by 5 by 18, and it will become meter per second. Okay, so we have to multiply with this. So it will become z into 18 by 5 kilometer per hour. Okay, now question number. A pair of shoes cost is rupees x. So a pair of shoes, cost of this is rupees x, and the cost of a dress is 200 more than 5 times the cost of the shoes. The cost of a dress is rupees 200 more than 5 times the cost of the shoes. Means the cost of so we have to write in a algebraic equation. Okay, the cost of a dress is 200 more. 200 more means plus 200, then 5 times the cost of the of the shoes. So 5 times of the so 5 times of the cost of shoes. Cost of shoes is x. This is cost of shoes is x. So x is the cost of shoes. So 5 terms of this number is 5x, and it is saying 200 more plus 200. So this is in this way we have to write this equation. So okay, so this is the cost of dress. So in this way we have to write these algebraic equations, expressions. Okay, so we have completed our exercise 11a.